Hi everyone. As Jeff said, I'm Elliot Wilm. I'm project manager with Walsh Construction, working on the Wolf Point development in Chicago. So brief history, brief history on Wolf Point. Chicago's broken up in an east-west and north-south river. It's called the Y, municipal symbol. You'll see all over Chicago. Right at the point, kind of like in this lower left corner here, is actually the first developed land in Chicago, called by the Kinsey family. And it was a tavern and it was a port. So that's where they would bring a lot of the materials into Chicago. So ironically, one of the first areas developed and also one of the last areas. Here's another circa 1893. Fast forward to 2005. Land is owned by the Kennedy family, President Kennedy family. They partnered with Heinz to turn essentially what the parking lot was to a much larger development. So this was the kind of rendering of what they started with. Comprised of a 4-story underground parking garage on the north side, which you can't really see. The building on the left is Wolf Point West. And then on the right side, Wolf Point East. And then dead center in the middle was Salesforce Tower, the case study revolving around. I've been there since the Wolf Point East and the Salesforce Tower, so the two right towers. I've been there for both of them. A couple key partners, Heinz and Kennedy family, developing partners. Clark Pelly designed the facade, if you will, of the river and most of the buildings downtown. HKS was our architect of record, MKA, structural engineer, obviously Walsh is general contractor and concrete. Quick synopsis I know about, this is about Salesforce Tower, but for Wolf Point East, just to give you an idea. 660-foot tower, 60-story residential building, over 50,000 yards of concrete. It's cast-in-place PT structure typically. Mild reinforced slabs. For the Salesforce Tower, about 840 feet, 58-story office building. So this is a structural steel slab metal deck concrete building. Ironically, there's about the same amount of cubic yardage at the end of the day, but it had included 10,000 tons of structural steel. So kind of what we're talking about today, the EPD analysis. So Heinz set out to really push tracking environmental product declarations throughout the process, or through the process. And they wanted to make it into a valuation on the buyout phase. So we tracked EPDs during the estimate and bidding phase and made it part of the evaluation of the project prior to award of either the concrete contractor, which was us, or the ready mix supplier in the background. So essentially what they did is after we got the job, or the general contractor, they implemented this bulletin which changed the highlighted language, which is kind of hard to read, but essentially requires a third-party certified Type 3 EPD, which at the time, in the Midwest, it was a little bit behind the 8 ball. We really weren't as up to speed as the West Coast on how to track this. So we spent a lot of time trying to go through this. We probably spent about a year and a half to really develop exactly how to track and get that Type 3 EPD. So when looking at, from a buyout standpoint, we know easy ways to reduce global warming potential is to remove cement, start adding admixtures, etc. It comes with some significant drawbacks times. So on the Wolf Point East project, we had a 3-day cycle on the slab, on each of the slabs. We would pour the slab and frame about half to 3/4 of the next deck the same day that we poured it. The only way to do that is to either pump in 20 million BTUs heat underneath the deck, or to add a ton of admixtures, which has diminishing results once you get past 2 hours. So that we're pretty sensitive about tracking and reducing too much cement to create other issues. And that is absolutely applicable on Salesforce Tower with our core wall design. We started off getting what we call like a self-declaring EP, which is how the Midwest, most of the East Coast, I would say, operates. In our case, it was Athena, the aggregator, and it was using essentially industry numbers, realistic numbers that backtrack where we were as relative to NRMCA records. So if you're pouring a 5,000 PSI 20% slag replacement mix, We know the industry standard for the Midwest is X amount of kilograms of CO2. And when doing so, we came up with, it's going to be a little different than the number on there. Kind of hard to see the red number down the bottom, 27%. We actually came up with 26% under industry average, which at the time was, I think, slightly exaggerated in the sense that industry average numbers are pretty conservative to try and get some involvement. So this sufficed for buyout. We were able to award the job. We were able to pick a ready mix supplier and start rolling them. But in doing so, they still pursued the Type 3 the independent certified EP, which we did. So then we went backwards, back to here. So then we went with Climate Earth. Prairie was our ready mix supplier. You get the Type 3 Climate Earth, goes to Prairie's yard. They give us the new numbers. Turns out instead of 27%, 26% under industry average, we're actually 2% over industry. So obviously, everyone backtracks trying to figure out exactly how we got here, what happened, and where they're getting their numbers from. And what it came down to is the main push behind the EPD process and the Type 3 portion of it was to put pressure on the suppliers. Namely, two suppliers. It's going to be lightweight aggregate and cement. They're going to try and figure out how to make those processes better. So what they did is numbers, the industry average numbers that the self-declaring processes were including, which were more realistic, they were exaggerating them to put pressure on the suppliers, not the even ready mix. So that was part of the reason why that was so much higher than it was. So at the end of the day, we ended up back at 27%. So we were actually 1% further reduced off of the NRMCA baseline numbers. Long story short, once St. Mary's and Lafarge's cement manufacturers, suppliers, they actually got certified in addition to the supplier. So the supplier necessarily cannot give you Type 3 certified EPD unless the products coming into it are also certified. Namely, it's really cement. So that was kind of the big push, I would say, here. Obviously, this is our tracking log in progress. See how we were shaking out with floor wall mixes, our slab metal deck, etc. We had quite a bit of lightweight slab metal deck concrete mix, quite a bit of our 12,000 psi floor shear wall mix. Kind of as an animal all of itself. Speaking of kind of the larger amount, so as you get higher in the PSI world, there's less data on it. So one of our mixes actually had a 12,000 psi, no cure date time. So one of the things, what we've noticed is that a lot of the engineers are going away from dictating certain compressibility at a certain 28-day prime C's got to be 6,000. They're no longer doing it. Saying however long it takes you to get to that number, it doesn't matter as long as we get the end properties. Allowing us to kind of change around the mixes. So kind of tying this into the buyout phase, shear wall mix, 12,000 psi. We spent probably about 2.5 years kind of really developing this prairie. When we first started, it was hitting 260, 270 degree temperatures, tons of cement. We then kind of went back the other way, made it was setting pretty slow. So we kind of fine-tuned it. For our Salesforce Tower core schedule, it's very critical. We had to pour a new core every 4 days. Talking about a 250, 300 yard pour. Quite a bit to do to try to make that time frame work. If they wanted us to reduce it further, we were able to. Kind of between Athena and then Climate Earth, we were able to kind of develop a cost analysis saying, for instance, our 27%, we could have achieved 42%. If we were to remove a lot of the cement out of the core wall mix. I actually had to use a combination of 4 different admixtures, which added a significant cost too. So, really allows us to play around with this. The good part is that a lot of the development that we did on this project, same Excel software, if you will, of tracking these different types and what if I do this or what if I do that? You can do it real time. So we can do it during bidding phase. We can tell you, here, if we can go to a 4-day cycle instead of a 3-day cycle, this is the mix we can use to reduce production. As far as some design implications here, just some design criteria of the job. The building was a podium and a concrete cast-in-place podium, 2 levels, with typically 76-foot caissons down to hardpan. And then in the main core itself, around the perimeter steel columns, we had 15-foot bells. In the center of the building, underneath our core walls, we actually had 9 10-foot diameter caissons, 8,000 psi, with 1-inch thick casing all the way down that came out as one piece. Then we actually socketed about 10 feet into the bedrock itself to prevent uplift from affecting the case. So this is a typical floor slab. Once you get past level 7, this is level 8 and above. So this is our standard floor plate. Kind of hard to tell, but the bays themselves are about 30 feet left-right direction, about 40 feet up and down. So pretty large spans, 3-inch deck, 3 1/4 inch lightweight aggregate concrete. The lightweight concrete helped the engineer use quite a bit of the steel framing. On the lower slabs, we were 2 to 3 extra beams in between every single bay in order to achieve enough composite action in the slab itself. So that's the standard, like I said, that's the standard floor. That's where most of our yardage really is. From a core shear wall design standpoint, again, their big push on MK was high EMOD, so high elasticity to it, but very brittle but very strong core wall to handle some of the lateral pressures. To give you an idea of the kind of general design, there's a few different ways in Chicago that we typically will support the lateral design. Either with upsizing the core, which obviously can have some detriment. We are able to use essentially a stilt option. So the good analogy I've used in the past is it's kind of like a skier. You're skiing, your legs, body is the core wall, and you have your ski poles. Essentially upsize the exterior columns, as you can see kind of in that second photo from the left. Kind of act as the poles themselves, and then you have these large outrigger systems that come off of the core out to those exterior areas, essentially widening the core footprint about 3 times what it normally would have been. And it's mainly for serviceability in these high rises. So there's actually minimum area steel required for the core wall design, except for a couple minor locations. They were able to achieve that with this kind of lateral system. And then this is kind of a cross-section of what that lateral system kind of looks like. So you have these 20,000-pound embed plates, the ones in green, that actually are cast into the core wall, and they extend out to out and outrigger trusses. So you have a truss running left-right, and then up and down at each of those highlighted locations to have really kind of stiffen that upper foot. Here's an example of that kind of tie plate. Kind of a quick time lapse of the building. So I know I kind of ran through it. Wanted to leave time for Q&A if there's any questions about any of the EPD tracking along the way. I know it's kind of a cumbersome process of back and forth, so if anyone has any questions.
Thank you for excellent presentation. So you mentioned that it was a requirement to use EPD for this project. If there wouldn't be any requirement from the owner, do you see any incentive for the contractor to use EPD to appraise their own performance or save money or time?
As far as the EPD production, that was a good question. As far as the EPD production itself, it doesn't do any good for us to present. I mean, it doesn't hurt us, doesn't help us, it kind of is what it is. We've been providing EPD since I've been in the industry for about 9 years. So My first project we provide, essentially it was a very reduced version of what this is now. But the last two projects, so the Wolf Point East one, we provided a Athena aggregators, kind of self-declaring EPD. And then the next one, we provided the Type 3 Climate Earth certified EPD. It's no skin off our backs to provide it, not provide it. The biggest thing is the material selection and the amount of pozzolans. So it actually kind of works out well that a lot of the foundations for all these are mass concrete. So mass concrete, you're trying to limit the amount of temperature you have in those areas when you have a 1,000-yard pour. So when we were doing that, we ended up using low cement mixes anyway. So it kind of worked out that we were probably a 40% reduction. So it's a good story for us to present. It's a good story for the developer. They actually created a handbook on it. So it's standard now. So at this point, we won't really ever submit. Actually, my current project now, they didn't require it. We still provide it. It doesn't hold anything back on our. Yeah. So good question. The question is about using an analysis done on using lightweight versus normal weight concrete in the slab metal deck. That analysis was done by the engineer MK. They decided it was much better to have lightweight concrete on the typical span. So inside of the core walls, where everything's tighter spaced, a lot more penetration through it, a lot more mild reinforcement in the slab, they did use my normal weight. But all the exterior, all lightweight concrete. I think it had a slight effect on fire rating. I think it had a large impact on the actual weight of the slab itself. I know our slabs are pretty much designed within 2-3% of its capacity. So right off the top, if you were to back for a second, if we were to look at, so right now we're about 17 million kilograms of CO2. Right, that's what we're going to come back to. The slab metal deck itself, you would add a whole nother beam, W21 by 57, at every single base. So you're probably looking to add another couple million kilograms of CO2, specifically to add that additional steel to stiffen it up to use. It was that close, given their base. So yes, the analysis was done. It was done, I would say, during the very beginning stages of our involvement. That was done with MK, who was really an expert on the topic of the whole EPDs. They actually made us part of the requirements also to utilize EC3. For those of you who don't know, EC3 is just an online tool for tracking these Type 3 certified EPDs. You can go on there and see exactly where the baselines are. You can see exactly where your mix has been. So now every single mix that we used on this project, I could give you the mix number. You could go on to EC3 and you could find out exactly everything you want to know about that. Which has been a big push for the EPD tracking in of itself, is to develop from the supplier out what's in the mix, how is it being produced, and that's why, again, they're focusing on lightweight. Sure. No, there wasn't. So we did look into nylon, I want to say, fibers. So we did look at a couple different options, but for the most part, no. Steel fibers were. We did have concern. I will say we did have concerns about pumpability. That came up, and it turned out actually not to be a big issue. We had one blowout, and it was because of a coupling.
Did the use of the lightweight concrete impact the crane picks for the beams that you didn't need to put in had it been normal weight, and how was that accounted for?
Sure. Yeah, that's a great question. So for steel erection in and of itself, everything from an estimate standpoint, from a cost standpoint, everything comes down to picks. So each of those beams that you see, longer beams, every beam out there, I don't care how big it is, how small it is, everything gets picked by the crane, piece by piece. It has to be installed piece by piece. You're not going to pre-assemble a floor and then set the whole thing in place, especially given we have a whole set of elongation discussions here. So everything's a little tilted if you build the building like this and let it settle down over time. So every single piece is being brought from upwards of 1,000 feet down all the way on the slab, all the way up to where it's being set, then gets installed. So any excess pieces you can eliminate helps it out. It's taken into account in the bid. Answer. Simple answer. If we were to add an additional beam, you have 15 beams, it would take one tier or two floors to add another day to the schedule. So you're looking at $40,000 a day for a steel erector to be. You'd be adding millions of dollars. So if you can eliminate and make those longer spans, it does make a schedule and on cost from the steel erection, in addition to concrete. One other interesting, just while we're talking about this, one other kind of touched on but didn't really. We had 10,000 tons, so initially I'm sure you've all heard concrete is the biggest global warming potential discussion on a building. That was my understanding early on. After this process, realized that's kind of not true. So if you isolated just our tower footprint, eliminate the concrete podium, even keep the concrete foundations, the amount of global warming potential included in the steel was the same, almost identical to the amount of kilograms of CO2 in concrete itself. And so there was this kind of epiphany on MKA and EC3 and all these other entities when trying to figure out, all right, well, what other epiphanies are we going to get? We never knew until we got to this layer of it. So then they figured out, so we started helping them show this is how much copper we have in the building, this is how much cast iron we have, this is how much electrical. And so they started looking to all these other sectors as well. I found that to be pretty interesting, that actually structural steel accounted for about the same global warming potential concrete. Sure. Yeah, we did. So, kind of hard to tell. River. Bottom of the foundations were about 20 feet below the bottom. And when we dug down, we actually encountered two of these coal tunnels that were able to transport coal from one side of the river to the other side without going over the. So any project that encounters those tunnels always have the same job, essentially. It's not in the way of your site, bulkhead them off on both sides. So we drill holes in on the north and south sides of our site, dig down, and we build a concrete bulkhead wall. It's about 4 feet thick, and then we bury it. So the tunnel's still there, but there's no way to access it. If you were to get into, say under like McCormick Place, there's even, not all of them are capped, but most of them. So yeah, we ran into two of them. All right. Thank you.